Okay, so in our last series of videos, we'll be talking about exponents and bases. The three videos quite interesting. I would like you to take a look at them so that helps you to understand this better. We're going to move into what we call logarithms. Why logarithms? The aim of studying logarithms is actually to linearize variable powers. What do I mean by that? Is actually to take out powers that are variables, or powers, not just variables, even constant powers. How do we manage these powers and these exponents? And that can only be done by the use of logarithms. So that's what we're going to discuss. So logarithms, you see things written like this: log, let us say log x base n. So this is how it is written. I'm going to explain everything here, and let us say this is equals to c. So this is how logarithms are written. So I'll explain everything right there. I'm sure you've seen all this, you've been saying this, so I'm going to explain that. So this m here is actually the base by the foot of the g. See, by the foot of the g, that is actually the base. So m, you can call that the base. This is actually called the argument. And not like arguments where you have a face-to-face discussion with somebody, but this is the argument that has to do with the domain value. So x here is called the argument, and c is actually, funny enough, the power, the exponent. So the exponent. So sometimes I always advise students to do this. I always advise students to always have this in your head, because this will give you a smile. You all remember, because of b, you remember that's the b, this is the exponent, and that is the argument. So if you want to do that, it's okay by you. So this is basically logarithm for you, and that gives you, that will actually help you to always rewrite this. Will help you to rewrite this, because if that is true, then this can be written as b raised to the power of e equals to a. Why did I do this easily? Because I know this is the base, this is the exponent, and this is what you have the argument. So if it's actually the base is always having the power. So the base is going to be having the power. So sometimes I always teach students to do their hands this way, man, anti-clockwise manner. Yeah, anti-clockwise manner. So you can go this way. So if you have log, if you have something like this, it simply means 2 raised to the power of 3 is equals to 8. That is true. So this is another way you can write bases and power. So very interesting. So we call this the logarithm form, and we call this the indicial form, or what we call the index form, or what we call the exponent form, or what we call the hyperbolic form, or whatever. So that is what we have. So this is logarithm for you. Sometimes logarithms are written without the b. Sometimes you see something like this, log 5, or something like log 3. Once it is written like this, the base is actually base 10. So this is actually base 10. So it's actually the way we write logarithms. So instead of writing this all the time, once you see log 3, it's actually base 10, and that is it has a table that gives you this as this. So log 3 is actually 0.4771. You can check that out in your table. But we have what we call the Naperian logarithm. We have what we call the Naperian logarithm, or what we call the common logarithm. Another name for it is called the common logarithm. And for some crazy engineers, some of them call it hyperbolic logarithm. So what happens there is that the base is base e. Let's say x. That e is not actually this e we're talking about here. The e is actually what we call the Euler constant. It is approximately, the Euler constant is approximately 2.7182, blah blah blah. So this is what we call the Euler constant. And so when you have this in mathematics, we don't write this, we call it ln, ln x. So you see stylish ln like this. So you see that, you can try that. It's beautiful. So when you see something like this, ln 2 is actually log to base e and 2. All this I'm doing to actually explain the basics of logarithms. Now, what are the rules that govern logarithm? I will discuss the first two rules, and in the next video we'll talk about the other rules. So let's go with that. I'm sorry I have to take this out. Don't feel bad about that. If you need it, you can always rewind the video and discuss that. So the first rule is telling us when we have log to base n. Okay, let us use b because we're talking about b as base. Then we have a, and then another log base b. Then we have something like maybe c. It's a lot here, but just two things. I have two logs. I have these logs. I have their bases to be the same. I have two different arguments. I don't care, but I have same basis. I have the same log, and I have addition here. If all those conditions are met, please, all you need to do is to have a common base, then multiply this and this. I go over that again. So if I have the basis to be equal and I have an addition sign, please, all you need to do is to multiply the arguments. So you simply multiply the arguments. So don't be scared. All you just have, you have this log 3 plus log 5. Please, this is not log 8. This is simply going to be log 15. Why is it log 15? Because my bases are the same. The hidden base, which is base 10, I can simply multiply 5 times 3 and it gives me 15. This rule, which I will call number 1, we have the second rule. And the second rule is actually very interesting. The second rule is saying if we are to have same base, we have A, we have C, same thing happening, but if I change this to minus, almost the same thing happens, but it will be multiplication again. In this case, it's going to be what? Division. It's going to be division. So these are rules, please, and we shouldn't joke to them. So if we were to have something like log 2x minus log 3x minus 1, scary looking mathematics. The simple thing is that we have two logs, the bases are the same, which is base 10. Just simply write a single log to represent the two logs, and since this is subtraction, we are going to have 2x divided by 3x. That is what the law is telling us to do. I round up by the third law, and the third law is simply telling us that if the base and the argument are the same, wow, everything is going to be 1. Do you believe that? If you doubt that, simply change this to the index form and see what you're going to have. So simply change it to the index. Do you remember how we do that? The base raised to the power, the base raised to the power. Are we going to have this? So the base, which is b, raised to the power 1. And you see, it's going to actually give us the argument, which is this. So this is a rule that we must not forget. So we leave by discussing the fourth rule, which is very important. And that also tells us that if we have this, is going to give us. Is that true? Yes, that is true. Because if we rewrite this as b raised to the power of 0, and you see that is actually 1. That is true. So please, I have discussed 4 rules. And the first rule is this, the second rule is this, which has to do with subtraction and where we divide the arguments. The third rule, where the base and the arguments are the same, we have 1. And finally, if we have log 1, just log 1, whatsoever base, log 1 is actually 0. Please take note of this fourth rule. In our next video, I'm going to be discussing the remaining 4 rules. We have so many rules of logarithm, but these are basic. And whatever rule we are going to be having, it takes their step from this. Thank you very much. Subscribe.